Hello, everyone. So today we are going to go through the notes for 7.6. This is almost the last section we have in Chapter 7. We're going to spend 2 days on this, but I'm really just going to record one video for the 2 days. There's really not a lot we're adding in the second day. We just want kind of 2 days worth of practice. So this is the video I'm going to post for Monday and Tuesday. This is one of the harder topics we're going to go over in regards to factoring. So if you're on B day and you're trying to watch this on Monday and it's not really making sense, don't panic. I will go over this in class on Tuesday. Watch through it, give it your best shot, but I am going to go over it. So don't worry too much. Just, maybe save some questions if you're a little bit stuck on some things. I think we've gone through most of these vocab terms already. We're on page 231 there in your student journal if you want to take notes along with me. The problems that we're going to do today, instead of being set up like one of the ones we've seen before, like let's say last week I could have given you a problem that looks like this: x squared plus 5x plus 6. And I tell you to factor it out. You'd come up with your little x. You'd say, okay, well, 5 goes in the bottom, 6 goes in the top, and I'm thinking of the two numbers that add up to 5, my middle term, and multiply to 6, which is my last term. And I'd come up with 2 and 3, and I'd say, awesome, okay, x plus 2 times x plus 3. Okay, and that would be that factored form of the polynomial that I had. The problems that we're going to be doing today, we're not going to be looking at anything that just has this x squared term in the front. We're going to be looking at this very specific type of polynomial, this type of trinomial, where the a, I talked about this a little bit last week, we call this like ax squared plus bx plus c. Right now, the a is always 1, where you have just x squared or n squared or whatever. But now we're going to say, okay, well, now the a is not just 1. Now the a is 2 and 3 and 4, and it can be any number. So that first number, that first coefficient before that x squared term, can now be any other number. And that changes how we solve the problem. Sometimes it's a simple fix. Sometimes you can look, and let's see if there are any. Yes, there's some right here. So sometimes it's like last week. There were a couple problems like this on our factoring sheet that we did that first day, 7.5 day 1, where we would look at these and go, oh, okay, well, this is easy enough. I can just factor out a 2. I can say, well, if I divide a 2 out of this whole thing, some of us, we would do this, but we would forget to leave the 2 on the outside. The 2 still has to go on the outside. Okay, but I'm going to divide everything right here by 2. Okay, so I'm just left with c squared minus 7c minus 18. Right, and I would think of, okay, what are my factors of negative 7? Now I've got a normal trinomial I can just factor. My factors of negative 7, my factors of negative 18 that add up to negative 7. I said that backwards. Okay, so my factors of negative 18. So now I have one positive and one negative because I want it to add up to negative 18. I'm going to make that look like negative 18 and not plus 8. So, okay, I'm going to be dealing with 9 and 2. And, okay, the 9 should be negative and the 2 should be positive. So I'm going to leave my 2 on the outside. I'm going to have x. Oh, no, it says c. C plus 2 and c minus 9. Okay, and that would be my factored form. Okay, so that's one method that you can do, and we talked about that a little bit last week. I think everything in this first little chunk, you can just take out whatever that GCF is. If I talk about GCF factoring, that means I'm just dividing out one number or one variable out of your whole trinomial or binomial or whatever. But some of them, if we look over here like at 7, there's not just one there's not just one thing that I can divide out of this. I can't divide out of 2, I can't divide out of 3. Right, so I'm going to have to use some different methods here. So 7's giving me some nasty numbers. So I'm going to show you problem 8. Let's go back to 231 because I've got a bit more space to show you. There's 2 different methods that we can kind of use for this type of factoring. And I don't really care which method you do use. Whatever makes more sense for you is great. But I'm going to show you both. Let's go back up here to 231. Oh, I already forgot the problem. 6k squared minus 11k plus 4. 6k squared minus 11k plus 4. I'm going to double check. Perfect. So there's 2 different methods, and I wrote them down here. We've got grouping and what I call slide and divide. I think that grouping is the better method just in terms of all of the processes kind of make sense to me. They're all kind of normal things that I can do in algebra, and the slide and divide is more of what I kind of call math magic, where it works every time and there's kind of a system to it, but it's a little bit, for me at least, harder to remember all of the steps, so it's really easy to make a mistake. Okay, but with either one of these, definitely make sure you get down all the steps in your notes. Okay, so with grouping, okay, you start with your original. Okay, so 6k squared minus 11k and then plus 4. So I can make my little X, my little graphic organizer, but instead of just using C here at the top, you want to use A times C. I'm not thinking of my factors of 4. I'm thinking of my factors of A times C, so 6 times 4. I'm thinking of my factors of 24 that add up to negative 11. And it's still going to be even more complex. You might be thinking, oh, I'm just going to use K. I can think I've got 2 negative numbers. So if I look at my factor sheet, I can see, okay, 8 and 3. I know it's going to be negative 8 and negative 3 since it's adding up to negative 11. But it's not as simple as normal factoring. So don't just go back on autopilot and say, okay, cool, K minus 8, K minus 3, I'm done. Instead, you have to kind of split this negative 11k and say, this isn't negative 11k anymore. This is negative 8k. So let me write that out. Negative 8k minus 3k. Because think about that. If I were to combine like terms, that would combine back to 11k. So I'm just going to split it into those 2. And I'm going to leave this 6k squared the way it is and the plus 4 the way it is. Right? So then what I'm going to do is I'm going to group this first chunk, this 6k squared minus 8k. Okay, that's going to be one group plus negative 3k plus 4. And I know this looks weird. This is not any type of factoring we've looked at before. Okay, but essentially what we've got to do here is we're going to factor something out of this first group, and then we're going to factor something out of this second group. Okay, so first off, so we're thinking this is like the factoring we started doing like 2 weeks ago, where I'm thinking, what can I divide out of both of these terms? Well, I can divide out a 2 is a common factor here, so I can divide out a 2. And I've got a k on both of these terms, so I can divide out a 2k. Okay, so 6k squared. If I divide this by 2k, I'm going to be left with 3k. And then negative 8k, same thing, going to divide by 2k. And I'm left with negative 4. Alrighty, I'm going to do the same thing. And I don't really have any common factors here with negative 3k and positive 4, but I'm going to tell you that my goal here with grouping is to say I want the same, I want both of these two parentheses to be the exact same. So what I can do to make that happen is I want to get rid of a negative 1. So actually I put a plus, but really I'm going to put a little minus 1 because I want to divide out a negative 1 from each of these. So I'm going to end up now with positive 3k minus 4. Okay, see what happens when you factor out what you need to from each one of these two groups? You should end up with 3k minus 4 and 3k minus 4. You should end up with two copies of the same binomial, whatever's in those parentheses. And then what you're going to do for that final step is you're going to say, okay, the two terms on the outside, so I have a 2k and a negative 1, that's going to make up one of my parentheses, 2k minus 1. And then what you have this two copies of, this 3k minus 4, that's going to be your second set of parentheses, 3k minus 4. Okay, and if you're sitting here going, oh my gosh, that was so confusing, don't panic. I promise the other one is way easier. Okay, this is your final step. I kind of prefer this method just because I think all the steps kind of make sense algebraically to me. But if you're sitting there going, oh my gosh, I will never remember all these, it's okay. We've got an easier method over here, the slide and divide. Okay, so don't panic quite yet. So slide and divide, I think, is a little bit easier. I'm going to do the exact same trinomial that I did over here. So I'm going to say, okay, I'm starting off with this 6k squared minus 11k plus 4. So for slide and divide, we're going to do the same problem. So you can see that it works the same no matter what. It works for all the same types of problems that we would do for grouping. But I think for a lot of people, we find this process a little bit simpler. Essentially, what we want to do for slide and divide, the first thing you want to do is basically you're going to take this first term, this a, just the coefficient, I mean, and you're going to divide it by this c. Okay, and this is part of why I'm not crazy about this method sometimes, because it's kind of, there's really nothing in algebra that says we're allowed to do this. This is kind of just one of those math magic things that just works because it's a trick that always works. But here we go. We go then and we say, okay, we've got k squared minus 11k, and now 6 times 4, I get 24. Right? So then we start out by factoring this like normal. The way that people mess this method up is they go, okay, cool, I divided the a times the c, they factor it out, and they go, cool, I'm done. But there's extra stuff we have to do at the end. So let's not forget about that. But for now, we're going to draw our x. We're going to say, okay, we wanted to add to negative 11 and multiply to 24. Notice this is the same x that we used before. We're doing the same math. We're just using a different method. Okay, so we were going to end up with negative 8 and negative 3 again. I'm going to say, okay, I'm going to start out by saying I've got this k minus 8 times k minus 3, right? And the thing that you then have to do with slide and divide is you then have to go in and say, well, I came up with negative 8 and negative 3 when I had modified my trinomial. I started out by multiplying this number by 6. So to even this back out, I've got to go through and divide both of these by 6. Okay? So this ends up being k minus what is this going to be? 4/3. And then 3/6 is going to be 1/2. And with factoring, we don't really like leaving these fractions right here. So to kind of undo these fractions, you take these denominators and you put them out in front of k. So I get 3k minus 4, and I get 2k minus 1. Okay, the exact same answer we got over there. Again, the order of the factors doesn't really matter. Okay. So tomorrow I'll post a video. For Tuesday, I'll post a video of just kind of some more examples, because I think for either of these processes, it just takes some time and some practice. Okay. So that's what I'll try and do when I see you in class. If you feel like or if you're an A day or B day, or if you're just on quarantine, I'm going to open up a Google Meet during 5th period if you would like to join. I think that's 116. If you want to join, go ahead and do that. And please feel free to email me any questions. I know this past few weeks has been a little bit stressful if you're in quarantine or getting back in the habit of hybrid and all that stuff. So just reach out if you are struggling. Let me know if you have any questions, and I'll see you guys soon.